Welcome back to my channel Chemistry Made Simple for NEET. I am Dr.Lekshmy Subramaniam with a PhD in Chemistry. Please do like, share and subscribe to my channel. In today's session, we are going to study Polymers, Unit 15, Class 12, NCERT Chemistry. Now, what are polymers? The word polymer comes from two Greek words. Poly means many and mer means part or unit. So, we can define polymer as a very large molecule having high molecular mass, and they are also called macromolecules formed by joining repeating structural units on a large scale. The repeating structural units are derived from some simple and reactive molecules called monomers and linked to each other by covalent bonds, and this process is called polymerisation. So, the transformation of ethene to polythene and interaction of hexamethylene diamine and adipic acid forms nylon 6,6. These are examples of different types of polymerization reaction. So, again we can just do a recap. Polymers are made of large number of macromolecules. Single unit of polymeric chain is called a monomer, and this process is called polymerization, and you can see ethene after undergoing polymerization. You can see the repeated chain n times, and finally polythene polymer. You can see that the n comes on the right side now, and also from hexamethylene diamine plus adipic acid, again polymerization gives nylon 6,6. This structure is very important. Please do write and learn this structure. Next, what about the classification of polymers? They are mainly classified into one, natural polymers found in plants and animals like protein, cellulose, starch, resins and rubber. Then second is semi-synthetic polymer, cellulose derivatives like cellulose acetate, rayon, cellulose nitrate, etc. are the usual examples. Then synthetic polymers, like a variety of synthetic polymers that is artificially made, like plastic, polythene, synthetic fibers like nylon 6,6, synthetic rubbers, buna-S. So, these are all man-made polymers which are extremely useful in our day-to-day life as well as in industry. So, these are all based on the structure of polymers. Now, what are structural polymers? So, three different types based on the structure of polymers. One is linear polymer, like having long and straight chains, and examples are polythene, polyvinyl chloride. You can see how they are represented. Then branched chain polymers, like they have linear chains with some branches like low density polythene, and which is shown in the figure below. Now, next we have cross-linked or network polymers. So, usually formed by bifunctional or trifunctional monomers, and they contain covalent bonds which are very strong between different polymer chains like bakelite, melamine, etc. And you can see how they are formed in the figure. Now, what are addition polymers? So, these are formed from repeated units of monomers having double and triple bonds. So, they are formed by addition of two different polymers which are called co-polymers. So, you can see the formation of polythene from ethene and polypropylene from propene, and addition of polymers formed by polymerization of a single monomeric species. They are known as homopolymers like polythene. So, from ethene you can get polythene, and which is a homopolymer, and the polymers made by addition polymerization from two different monomers are called copolymers like buna-S, buna-N, etc. So, you have to study the structure well, and you can refer to the NCERT textbook also for the structure. Now, we have got condensation polymers which are formed by repeated condensation reaction between bifunctional or trifunctional monomeric units, and in this you can see the elimination of small molecules like either water or alcohol or hydrogen plus chloride will happen. So, examples are terylene, nylon 6,6, nylon 6, etc. You can see in the structure given below, and this is also very important, and at the considering the examination point of view. Now, classification of polymers based on molecular forces. So, many polymer applications in different fields actually depend on unique mechanical properties called tensile strength, elasticity, toughness, etc. So, these properties will determine the intermolecular forces like van der Waals forces, hydrogen bonds, etc., which are present in the polymer. And they also, these forces bind the polymer chains, and under this the polymers can be classified into 4 subgroups on the basis of magnitude of intermolecular forces present in them. And elastomers are rubber-like solids with elastic properties. Here the polymer chains are held together by weakest intermolecular forces. So these permit the polymer to be stretched, and a few crosslinks are introduced in between the chain. And what is their purpose? It helps the polymer to retract or come back to its original position once you release the force, just like a rubber band, as in vulcanized rubber. Examples are bunais, bunine, etc. Neoprene structure is given here. You will be asked to identify, after giving the structure, the name of the compound. So you have to know all this. Then what are fibers? These are thread forming solids which has high tensile strength and high modulus, and the characteristics are attributed to the very strong intermolecular forces like hydrogen bonding, and these forces results in close packing of chains and also impact crystalline nature. Examples are polyamides, polyesters, terylene, nylon 66, etc. Then we have got something very important known as thermoplastic polymer. So what are thermoplastic polymer? So these are a straight chain or linear, or even it can be slightly branched long chain molecules. It gets repeatedly softening on heating, and it again hardens on cooling. And these polymers has intermolecular forces of attraction intermediate between elastomers and fibers. So common examples are polythene, polystyrene, polyvinyls, etc. PVC, it's important. You can see the structure given here. Then thermosetting polymers. So these are also cross-linked and heavily branched molecules. When you heat them, they undergo extensive cross-linking in molds, and again they become infusible, but you cannot reuse it. So common examples are bakelite, urea, formaldehyde, resin. Bakelite structure is given in the page, you can see this. Then classification based on growth polymers. So there are 2 broad types of polymerization reaction. One is addition or chain growth polymerization, then condensation or step growth polymerization. So what is addition polymerization or chain growth polymerization? So here some monomer, same monomer molecules or different monomers will add together on a large scale to give a polymer. So unsaturated compounds are normally used as monomers, like alkenes, alkynes and their derivatives. So it leads to an increase in chain length, or chain growth can happen throughout the formation of either free radicals or ion species. But free radical governed addition or chain growth polymerization is the most common mode. And what is free radical mechanism? So when polymerization of ethene to polythene happens, it consists of heating or exposing to light a mixture of ethene with little benzoyl peroxide initiator. So first the process starts with addition of phenyl radical, which is formed by the peroxide to the ethene double bond, and you get a new and large free radical, and this particular step is called chain initiating step, which is very important. And then this particular radical form will react with another molecule of ethane, then another bigger size radical is formed. So this process, you can see, it keeps on repeating. The sequence get repeated with new and bigger radicals, and that will keep on carrying the reaction forward, and this step is termed or known as chain propagating step. So finally at some stage the product radical will react with another radical to form a polymerized product. So you can see the example of benzoyl peroxide here, and you can see that formation of phenyl radical. So benzoyl radical means you can see the 2 molecules like 2C6H5C COO, and from that you get phenyl radical, and again in the chain propagating step again you can see the reaction taking place, and finally the product, it's very easy. So you have to write and learn this product formation. And, you can see how this is formed in 2 steps, which is very important for the exam. And chain terminating step also, the long chain termination happens when the free radicals combine in different ways to form polythene. And you can see one method of in the previous step the final product formed is reacting to give polythene, and the formation of polythene, it's very important. And you see, even though you need not learn the structure by heart for MTA or for NEET exam, we cannot say what type of questions they ask on the basis of the structure. So always you have to remember, by looking at the structure, you have to know what is the product formed. So only then you will be able to answer the questions based on those particular reactions. All the different types of polymers and free radical mechanism, that is also very important. As I said, chain initiation step like benzoyl peroxide, you get a phenyl radical, those steps and all that you have to study those steps well. And you can refer the same note from NCERT. I have prepared this in a simple form, and you can refer to the textbook as well. Now, preparation of important addition polymers. First one is polytetrafluoroethene Teflon. Teflon is very important compound. Nowadays, you know that in kitchen and all we use utensils made of Teflon coating and all that. It's manufactured by heating tetrafluoroethane with a free radical or persulfate catalyst at a very high pressure. Chemically, it is inert and resistant to attack by corrosive agent. It's usually used in making oil seals, gaskets, and for non-stick surface coated utensils. You can see the tetrafluoroethane, CF2 double bond CF2N molecules in presence of catalyst and high pressure gives Teflon. You can see that the double bond breaks, and it is connected with single bond either side, and N molecules. So many molecules are combined together. So with that, we come to an end of awesome session of polymers. I think by looking at this quick revision, you will be finding the content very easy. And while preparing, you mark out the concepts which you personally find difficult in each chapter. Spend more time revising and solving questions based on these concepts. Write down the complex formulae and keep reading them over and over again in the last few days. So with that, we are coming to an end of this wonderful session for today. Please share with your friends as well, as they may find this beneficial for their preparation as well. Thanks for watching this video. I'll be coming up with the next session very soon. That's all for today.